What's more, the oil pressure isn't that high relative to the water pressure, so the oil doesn't have sufficient pressure basically to collapse molecular films of water and actually physically at the molecular basis contact the solid surface. If we're at the top of the field, however, the capillary pressure is much higher, the saturation is lower, oil has contacted most of the solid surface and at a high pressure, so it's pushed, it's squeezed its way onto the surface. So there you tend to see more oil wet characteristics. In between, you're seeing a mixture of wettability. Mixed wettability, actually like that generic capillary pressure curve I showed in the previous slide. So misconception number 2 is, the minimum water saturation that you may be able to obtain in a sample in the laboratory is not the saturation you're going to see in the field. That's controlled, obviously, by their capillary pressure height function. And furthermore, that may lead to a distribution of wettability within the reservoir. And that's particularly important because normally what you do in the lab, of course, you reduce the saturation down to its minimum connate or irreducible value here or close to it. And then you look at the water flood behavior and it's going to look like it's oil wet. And we're going to show, oh dear, that looks like it's bad for recovery. Whereas in the transition zone, where it's more mixed wet or water wet, the recovery can be a lot more favorable.